Hey there, this is a video for my 45SH students, my intro calc students. And this is the second in a series of two videos where I'm just going to use some technology to make my life easier for the stuff I'm doing for the examples in lesson 1. If you want to see the video that shows how I make these graphs that we did in lesson 1, then go watch the other video where I go to Desmos. But say you're doing these questions, say they're questions from a textbook where you don't necessarily have to produce the graph or even think very much about the graph, but you need to do things like fill in these chart values so that you can come up with an approximate slope of a tangent. And so you're going to have to basically kind of do the same calculations over and over again. Well, one thing I can do to make your life a lot easier is show you how I would do this on Excel. So let's start with example 1. This is the formula that I have to put numbers through, and it says that we have we want to know how fast the ball is moving at 4 seconds. So that means we kind of need this point here, which has an x-coordinate of 4. And when I was doing the example, I just pointed out that, well, we could run 4 through the calculator here, and let's see, that's negative 1.62579 times 4 squared plus 10 times 4 plus 15, and that gives me an answer of 28. I rounded it to 2 places in the notes, so 28.99. And then every time I need to find another point on this curve, like further down in the example, we have that point that we just found, 28.99, but then we decided we'd try to find the slope between another point and that point, and we picked 6, which meant that I had to then run 6 through the same formula to get the point that I got. I got 16.47 when I did it, but I will admit that I actually didn't punch that through the calculator again. It is kind of a drag, and then to make matters worse, when you go further into the example, you end up having to pick several other points of Q to work through this formula, and then on top of that you have to plug them into slope. So you have to find the slope between these points, and again the first one we found was 6, 16.47. Then you have to run values with decimal places through your slope formula. I honestly don't have the patience to do that, and you shouldn't either if you're just doing this for your homework. Feel free to use Excel. So let me show you how Excel can kind of make this much easier. Excel is very good at doing the same calculation over and over again. So let's start by putting in the x values that we want, or in this case the variable is t, not x. So in cell A1 I'm just going to put a t just as like a title. And then I'm going to just make a list of all of the x values I'm going to need. So the first one I found was a 4. Then we did the 6, which you saw me run through the calculator. Well, you saw me run the 4 through the calculator. After that, again, when I go to where we did the notes here, I think in class, let me just go back to where I wrote the notes down for class. Yeah, we then tried getting closer to 4. So we did 4.5, and then we did 4.01. And then we decided, well, let's try getting closer from the other direction as well. So we did so 6, 4.5, 4.01. Then I think we did 3.5, and then we did 3.9, and then we did 3.99. And in every single case here, I'd have to run these through this rather cumbersome equation with all these decimals that I got to punch in. Excel can make that a much easier process. So I'm going to put all of those x values in. So let me put them in here. There's 4.5, and then the next one was 4.01, and then 3.5, and then 3.9, and then 3.99. So there we go. So there's all the x values I'm going to calculate. Now to get the y values, or the function h of t values, I am going to need a formula. So to tell Excel you're about to do a formula, you hit the equals button, and that tells Excel that you were about to do a formula. So now I need to do the formula, and it involves, again, this equation right here, this function equation. So I'm going to punch that into Excel. I'm going to go negative 1.62579. And then I'm timesing it by t squared. Well, the t that I want is right here, so I'm going to call that A2. So because it's in cell A2. It's kind of like playing Battleship. So times is shift 8. You get that asterisk for multiplication. A2. Notice it highlights the cell that you're using, which is nice. And then I'm actually squaring that number before I times it. So it Excel follows BEDMAS, so I don't really need any brackets or anything. But an exponent is shift 6, which is the little hat, and then squared. And that's the only way you can do squared on Excel. And then plus 10 times that cell again, A2. And so now there's a constant of plus 15. So this formula here is this equation. So make sure that you can kind of see the logic of how that works. And then I hit enter, and there we go. There's that number that we got in our calculator. And if you're thinking to yourself, well, that was not less work than the button punch in the calculator, well, you're right, but here's what I can do that you can't do with a calculator. I can just shift, hold down the left button on your mouse and highlight this entire column, and then go up to here. The command is fill, and go fill down, and then it just automatically puts A3 in the formula and A4 in the formula and A5 in the formula, and it figures out all of the numbers that you need for all of the Y values. So now I can just read these off, go back to my notes, and I can just I can read this number here, which was the 16.47, which was right here, 16.47. And if I don't feel like rounding for myself, I can even round it. I can ask Excel to round for me. It can just decrease the decimals to 2 places. And again, if I go fill down, it does it for all of them. So there we go. So that's how I got my numbers for this chart here. So I can fill in the numbers here. So I got, let's see, 4.5 was 27.08, and 4.01 was 28.96, and 3.5 I didn't write down, so let me see what was 3.5 is 30.08. Oops, 30.08, there we go. So 30.08, oops, I said 08, and I wrote 88. 08, and 3.9 was 29.27, and 3.99 was 29.02, and there we go. That's how I got all those numbers. Now, next I have to actually get the slope from this point to this point. Remember how slope works, right? The slope formula is y2 minus y1 over x2 minus x1, right? And so I'm going to actually have to get this number minus that number, and then this number minus this number into here, and then I want to repeat that calculation in each one of these cells. So I'm going to do that in Excel as well. I'm going to find some slope values by going, okay, so what is y2? Well, y2 is this number here. Well, actually, I can't really find the slope between this number and itself, so I'm going to start down here. Right? The slope between this number and itself would be just 0 divided by 0, which is undefined. So starting at this point here, I want the slope of, this is my y2 and this is my y1. So I'm going to type that in. So I'm going to say that's going to be B3. Oh, I need a bracket because I'm going to be doing a subtract on top of another subtract. So BEDMAS, need brackets. B3 minus, now, when I want to fill this whole row or this whole column in, I want the second number in this formula to always be B2. See, I don't want to shift down to here and then have it go B4 minus B3. B2, this row here, this is always going to be the x1 and y1 of my formula. So what I do to make that happen is, instead of just typing in straight old B2, I type in B and then a dollar sign is the code in Excel. A code that says use this value constantly in the formula, and then close the bracket and divide by, and then open the bracket, and that's going to be 6 minus 4. But again, I don't want to say 6 minus 4 because it'll just calculate that one. I want to be able to bring this down after. So I want A3 minus A2, and I type in A3, but for A2, again, if I put a dollar sign between the A and the 2, that means it's always going to use A2 when I fill down the formula. So again, I hit enter, and it, oh, wait a minute, what happened? Oh, whoops, I forgot the equal sign. That's what happened. Equals, that's better. Now I hit my enter sign. There we go. And that was the number that you should remember from the notes that, again, I filled in right here. My slope was negative 6.258, right? And that's how I filled that in. Now, how do I get the rest of these numbers? Well, I get them by filling down. And now that I've put in this dollar sign, it'll stay A2 and B2, but then B3 and A3 will change to B4 and A4, and then 5, and then 6, and then 7, and 8. So I can just quickly fill down, and boom, there's the rest of the numbers that we got on that chart. Okay, want to see that one more time? Let's do the next example. So the next example had even more stuff. Example 2, let's go back to the workbook. Example 2, as you can see, had all kinds of x points. So I'm going to first of all type all those in. So again, my x values are going to be 1 and 1.5 and 1.9 and 1.99 and then 1.999 and then, oops, that's too many. Oh, no, it's not. That's right. Sorry, 3 nines. And then 1 point and then, oops, and then 1 point and 4 nines. And there we go. So there's the x values. And then, oh, and there was more. There was the other side of the chart. There was 3 and 2.5 and 2.1 and 2.01 and then 2.001 and then 2.0001, and then that was it. That was all the x values that we needed. Okay, the y values now are going to be from this formula here, which is x cubed minus 2x. So we're going to type that in. So my y values here are equal to x, and this is the first x I want, right? A2. And I want cubed, so I go shift 6, which gets me the little hat, and then power of 3. And then minus 2 times A2. And so that's an easy one to do in your head. That should be just 1 cubed minus 2 times 1, which is negative 1. But the rest of them get kind of ugly to figure out. So if you just fill down, it will fill them all in for you. It'll run them all through that formula. And that saves you a lot of button punching. Okay? Then those actually aren't entirely the numbers that I wanted. If you look back again, I didn't really want just the y values. I didn't really want f of x or f of 1 or f of 1.5 or f of 1.9. I want the slope. So I actually want the next thing. So let's see if we can do that slope thing again. So for the slope is going to equal, and again I should start here. Let's see, where is what is p? P is 2, 4. Well, p is actually 2, 4. So actually, yeah, we can start here. So the point that we're comparing all of these points to is 2, 4. So this time I'll actually just use 2 and 4. So it's going to be this value here, which is B2. So open a bracket, B2 minus 4 divided by A2 minus 2, right? And let me just show you, where am I getting 2, 4 from again? Oh yeah, because in the question, this fixed point here is the point 2, 4, right? Oh, there, it says it up there, the point 2, 4. So I'm comparing all of these things, all of these slopes are from the point 2, 4 to these new points here. So looking at that, I can now fill this equation down, and I will get all of the slopes that we got when we did it together in our notes. Okay, so that's how you can save a whole lot of time in your calculations by using Excel. Thanks for watching.